Hello guys, welcome to my channel. Please, after watching this video, please don't forget to subscribe. So today we want to focus on this concept on method of differences, right? So under this topic, method of differences, you should be familiar with the topic of partial fractions. Remember, most of the questions under method of difference, they ask you to partialize first, then after partializing, then you'll be asked to either to show or to express that given partial fractions in simplest form, right? So we are given the question 1a, and we are asked to show that 1 over r minus 3 over r plus 1 plus 2 over r plus 2 is identical to, remember this sign, remember we have 1, 2, 3 cosines, right? This one is identical to 2 minus r over r open bracket r plus 1 r plus 2. 2 marks is awarded for that question, right? And also we are given this question, part b, hence show that the summation of upper limit and lower limit r is equals to 1, 2 minus r over r open bracket r plus 1 r plus 2 is equals to r over n plus 1 n plus 2, right? Then 4 marks is also awarded for that question. Then also with the last part, and we ask to find the value of the summation of the upper limit infinite and the lower limit r is equals to 2 minus r over r open bracket r plus 1 r plus 2, and we ask to find the value of this summation, and 2 marks is also awarded, right? So alright, so let's first attack the first part, right? The first part we ask to show that 1 over r minus 3 over r plus 1 plus 2 over this one. So we are saying we have 1 over r minus 3 over r plus 1 plus 2 over r plus 2 should be equal to 2 minus r over r open bracket r plus 1 then r plus 2. So if you checked this question very well, 1 over r minus 3 over r plus 1 plus 2 over r plus 2 are the solutions after partializing this thing. If you partialize 2 minus r over r plus 1 r open bracket r plus 1 r plus 2 using the linear factor, this is your solution. So we want to reverse. So for us to reverse, then find the lowest common denominator of the given one, the left hand side. Let's consider the left hand side, right? Left hand side, right? So for left hand side, you are given r 1 over r minus 3 over r plus 1 plus 2 over r plus 2. Finding the lowest common denominator, the lowest common denominator becomes r open bracket r plus 1 r plus 2, right? So r into r plus 1 r plus 2, and you're left with r plus 1 and r plus 2 multiplied by the numerator, and it becomes r plus 1 r plus 2. Then r plus 1 into r open bracket r plus 1 r plus 2, r plus 1 you cancel r plus 1 and left with minus 3 is multiplying r multiplied by r plus 2, which is 3 minus 3 is multiplying, say, r squared plus 2r. Alright, then r plus 2 into the lowest common denominator, they will give us r plus 2, and we cancel r plus 2 and left with r open bracket r plus 1. So 2 is multiplying plus 2 is multiplying, say, r squared plus r, just because r times r, which is r squared, r times 1, which is r, right? Let's now simplify. Simplifying the first one, r times r, which is r squared, r times 2, which is plus 2r, then 1 times r, which is plus r, 1 times 2, which is plus 2, then minus 3 times r squared, which is minus 3r squared, then minus 6 r, then plus 2r squared plus 2 plus 2r all over r open bracket r plus 1 r plus 2, right? Let's now simplify the numerator. Simplifying the numerator, we are saying r minus 3r squared. R squared minus 3r squared, which is minus 2r squared, right? Minus 2r squared plus 2r squared to give us 0, right? This one and this one and this one will give us 0, right? Then 2r plus r to give us 3r. Then 2r plus r to give us 3r. 3r minus 6r to give us minus 3r. 3r minus 6r to give us minus 3r. Minus 3r plus 2r, which is minus r, which is minus r. So this one and this one and this one and this one will give us minus r, right? Then we are saying 2, we only left with the 2, right? Plus 2 all over r open bracket r plus 1 r plus 2. Alright, but we are asked to show that 1 over r minus 3 over r plus 1 plus 2 over r plus 2 is equals to 2 minus r, but now we have minus r plus 2, so we have to start with the positive value, which is 2 minus r all over r open bracket r plus 1 r plus 2. Then since we are asked to show, then you have to write shown. So this is how to show the first question, application of partial fractions using the linear factor, right? So we are done with part 1a. Please guys, after watching, please don't forget to subscribe. So let's move on. Part B, applying the method of differences to this one, so that since we asked to hence show that, hence means we have to use the answer above or use the solution above. You see some of the questions will ask you to hence or otherwise. Hence to use the solution above, otherwise you can use any other way besides the method above, right? So we ask you to use hence. The question sticks to hence, which means you have to use the expression above, right? So let's move on to part B. Moving on to part B. So we have summation of r is equals to 1, then n 2 minus r all over r open bracket r plus 1 r plus 2. This is equals to n over n plus 1 n plus 2. So question said hence, meaning we have to use the solution above. But remember, this expression is equal to this expression. So for us to apply the method of differences, then you have to partialize this first. So after partializing this 2 minus r over r open bracket r plus 1 r plus 2, the solution is here. If you partialize this one, or 2 minus r over r open bracket r plus 1 r plus 2 using the linear factor, here is a solution 1 over r minus 3 over r plus 1 plus 2 over r plus 2. So instead of writing this expression, then write this one to apply the concept of hence, right? So we are saying this is equals to we have 1 over r minus 3 over r plus 1 plus 2 over r plus 2. But remember, as it show that the summation of the lower limit 1, upper limit n, right? Which means from the first value is 1 up to the nth value. So we have to say when n is equals to 1, n is equals to 2, n is equals to 3, n is equals to 4, up to the nth value, right? Up to the nth value. So when r is equals to 1, then r is equals to n minus 1, r is equals to n minus 2, r is equals to n minus 3, r is equals to n minus 4, up to the nth value, right? So we are saying when r is equals to 1. So we want to see when r is 1. When r is 1, substituting, we have 1 over 1 minus 3 over 2 when r is 1, which is 1 plus 1, which is 2. Then plus 2 over when r is 1, which is 3. Yeah? Then let's consider when r is equals to n minus 1, right? Then right. Let's see when r is equals to 1. When r is equals to 1, then let's consider when r is equals to n plus 1. N plus 1. When r is equals to n plus 1, so substituting, like we might say, since when r is equals to 1, let's say r is equals to 2. When r is equals to 2, so we are saying 1 over 2 minus 3 over 3. Then plus when r is 2, which is 2 over 4. Then when r is equals to 3, when r is 3, which is 1 over 3 minus 3 over when r is 3, then plus when r is 3, when r is 3, it becomes when r is 3, it becomes 2 over 5. When r is equals to 4, when r is 4, it becomes 3 over, so it becomes 1 over 4 minus 3 over 5 plus 2 over, substituting 4 here, 2 over 6, right? Then let's consider when r is equals to n plus 1. When r is equals to n plus, wait a moment, when r is equals to n plus, let me check for the camera. Checking for the camera. Right. So we said when r is equals to 1 here. So we are saying since the lower limit is 1 up to the nth value, so when r is equals to 1, right? Then r is equals to 2, then we substitute here. R is equals to 3, substitute here. R is equals to 4, then we substitute here. Then remember, we want to find up to the nth value, right? So for the nth value, we are saying we can use this highest power, or this one, or this one, or this one. We can use this one. So we are saying when r is equals to, when r r, let's say when r is equals to n minus 2. When r is equals to n minus 2, so for r is equals to n minus 2, so we have 1 over, for n minus 2 minus 3 over, for n minus 2 it becomes n minus 2 plus 1, so minus 2 plus 1, which is negative 1. It becomes n minus 1. So when r is equals to n minus 2, for n minus 2 it becomes n here, plus n over plus 2 over n. Let's consider when r is equals to n minus 1. For n minus 1 here, it becomes 1 over n minus 1 minus 3 over, for n minus 1, it becomes r here. It becomes r here. Then, so it becomes n here. So it becomes n 3 over n. Then n minus 1, so it becomes n minus 1 plus 2 minus 1 plus 2, which is 1, so it becomes plus 2 over n plus 1. Let's consider when r is equals to n. So since the upper limit is n, so when r is equals to n, so 1 over n minus 3 over n, 3 over n, and 3 over n plus 1, 3 over n plus 1, and then plus 2 over, is equals to n is n plus 2, right? So since we're asked to show that this expression is equal to n over n plus 1, n plus 2, then we have to check the pattern. This pattern, we want to check for the sequence of the pattern, so that we show this expression is equals to this expression, right? So checking the pattern, if you check it very well, alright. If you say minus, we can check this pattern. We can use diagonal way of checking, right? If you say minus 2 over 3, minus 3 over 2 plus half cannot give us 0, right? Then let's consider this one. Minus is 2 over 3 minus 3 over 3. 2 over 3 minus 3 over 3, which is negative 1 over 3 plus. So we are saying minus 2 over 3 minus 3 over 3, which is minus 1 over 3 plus 1 over 3 to give us 0. So this pattern will give us 0. Might say this pattern here will give us 0, which means also this pattern will give us 0, right? Same apply to this pattern, will give us 0. Right. Same applies to this pattern, it will give us 0 also. Right. Same applies to this pattern, it will give us 0, which means this pattern also will give us 0, right? Using the fluent, since this value plus this value plus this value give us 0, then this value plus 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 this value to give us 0, this value plus this value plus this value to give us 0, which means since we ask it to show up to the nth value, then we can't cancel this one just because n is our upper limit, right? So we left with 2. We left with 2 over n plus 1, 2 over n plus 1 minus 3 over n plus 1 plus 2 over n plus 2. This is equals to finding the lowest common denominator. Our lowest common denominator here is n plus 1 and n plus 2, right? So n plus n plus 1 into this lowest common denominator to give us 2 is multiplying n plus 2. Then this one into this one to give us minus 3 is multiplying n plus 2. Then this one to this one to give us plus 2 is multiplying n plus 1. Alright, we have this part. Alright, this is equals to, simplifying the numerator, this becomes 2n plus 2, 2n plus 2, then minus 3n plus minus 3n minus 6, then plus 2n plus 2, right? Simplifying this one, 2n minus 3n, it becomes minus n plus 2n, which is n, right? Which is n, right. So this is n. Then this one gives us n. So 2, we have to say, alright, so we said 2 times n, which is 2n, 2 times 2, which is 4 here. 2 times 2 is 4. So we are saying 2 times 2n minus 3n plus 2n to give us n. So 4 minus 6n is minus 2 minus 2 plus 2, which is 0. So all over n plus 1, n plus 2. So this is how to show using the method of differences, guys. Thank you guys for being together. So since we asked to show that, then we have to write shown here. I'm sure after watching this video, please just subscribe and also share with your colleagues so that you enjoy more videos on this channel. Right, let's move on to the last part. On the last part, we've asked to find the value of the value of the infinite, right? I'll just explain on how to find the value of infinite, right? Part C, find the value of infinite. This find the value of upper limit infinite, lower limit r is equals to 2. Then 2 minus r over r open bracket r plus 1 r plus 2, right? For the infinite, right? For the infinite, when we're up to the infinite value, when the value is infinite, which means it's a smallest value, like 0.00000, maybe 0.0000001. It's an infinite value, right? So for the infinite value, if you substitute if a value of r by that small value 0.0000, which means if you say 2 minus 0.0000000 all over r is 0.0001 open bracket 0.00001 plus 1 open bracket 0.00001 plus 2 to give us, if we simplify that expression, which means in an approximately equal value of upper limit infinity lower limit r equals to 2 is 0. It becomes 0 here. It becomes 0. Right. This is how to find the infinite value. You see some of the questions. It's not always every infinite value give us 0. It depends with the expression given, right? It depends with the expression given, right? It depends on the expression given, and even if we use this expression to substitute when r is equals to 0.0000 or this one, if you simplify that expression, it will actually give you 0, right? Thank you guys for being together on this lesson. Please subscribe. Thank you so much. Let's meet on the next lesson. Thank you so much, guys.